explained, and the fact that there were 2 a day. A lot of other things became quite clear. Why the Earth is round, because everything gets pulled in. And why it isn't round, because it's spinning so that the outside gets thrown out a little bit and it balances. And why the sun and moon are round, and so on. Now, as the science developed and measurements were made ever more accurately, the tests of Newton's law became much more stringent. And the first careful tests involved the moons of Jupiter. By careful observations of the way they went around over a long period of time, one could be very careful to check that everything was according to Newton. And turned out not to be the case. The moons of Jupiter appeared to be first get sometimes to 8 minutes ahead of time and sometimes 8 minutes behind schedule, where schedule is the calculated values according to Newton's laws. It was noticed that they were ahead of schedule when they were close, when Jupiter was close to the Earth, and behind schedule when it was far away, a rather odd circumstance. And Mr. Römer, having confidence in the law of gravitation, came to an interesting conclusion, that it takes light some time to travel from the moons to the Earth, and that what we're looking at when we see the moons are not how they are now, but how they were the time ago that it took the light to get here. Now, when Jupiter's near us, it takes less time for the light to come, and when Jupiter's further, it takes longer time, so he had to correct the observations for the differences in time, and by the fact that they were this much too early or that much too late, was able to determine the velocity of light. This was the first demonstration that light was not an instantaneously propagating material. I bring this particular matter to your attention because it illustrates something. That when a law is right, it can be used to find another one. That by having confidence in this law, if something is the matter, it suggests perhaps some other phenomenon. And if we had not known the law of gravitation, we would have taken much longer to find the speed of light, because we would not have known what to expect of Jupiter's satellites. This process has developed into an avalanche of discoveries. Each new discovery permits the tools for much more discovery, and this is the beginning of that avalanche, which has gone on now for 400 years in a continuous process, and we're still avalanching along at high speed at this time. Another problem came up. The planets shouldn't really go in ellipses because, according to Newton's laws, they're not attracted only by the sun, but also they pull on each other a little bit, only a little bit, but a little bit is something, and will alter the motion a little bit. So Jupiter, Saturn, and Uranus were big planets that were known, and the calculations were made as to how slightly different than the perfect ellipses of Kepler the planets ought to be going, Jupiter, Saturn, and Uranus, by the pull of one on each other. And when they were finished, the calculations, I mean, and the observations, it was noticed that Jupiter and Saturn went according to the calculations, but that Uranus was doing something funny. Another opportunity for Newton's laws to be found wanting, but courage. Two men, both who made these calculations, Adams and Leverrier, independently and at almost exactly the same time, proposed that the motions of Uranus were due to an unseen as yet new planet. And so they wrote letters to their respective observatories telling them to look. Turn your telescope and look there and you'll find a planet. How absurd, said one of the observatories, that some guy sitting with pieces of paper and pencils can tell us where we'd look to find something new planet. And the other observatory was more, less, the administration was different. And they found the Neptune. More recently, in the beginning of the 20th century, it became apparent that the motion of the planet Mercury was not exactly right. And this caused a lot of trouble and had no explanation until a modification of Newton's. This did show ultimately that Newton's laws were slightly off and that they had to be modified. I will not discuss the modification in detail. It was made by Einstein.